In 2010, Caterpillar shocked the trucking world by exiting the on-highway engine market after decades of powering America's rigs. After building legendary engines for decades, Cat left behind many loyal drivers who had long depended on their yellow iron for the toughest hauls. This is the story of the Caterpillar 3406, the engine that promised truckers they could haul anything, anywhere, and always get home. For years, that promise held true. Then everything changed. When Caterpillar introduced the 3406 in 1973, American trucking was about to explode. The Motor Carrier Act of 1980 would deregulate the industry, unleashing thousands of independent operators who needed engines that could survive anything the road could throw at them. These weren't corporate fleets with scheduled maintenance. These were owner-operators betting their livelihoods on machines that had to work. They trusted the 3406 because an in-frame overhaul was straightforward. You could drop the pan, roll in bearings, pull liners and pistons as kits, set injector height and valve lash, time the fuel system, pressure test the cooler, and button it up without removing the block from the chassis. Most accessories were gear-driven, which cut belt failures. The design rewarded maintenance discipline and kept trucks earning instead of waiting weeks for a complete replacement long block. The 3406 was built for exactly this reality. At 14.6 liters of displacement, it was massive even by truck engine standards. The inline six-cylinder design featured a 5.4-inch bore and 6.5-inch stroke, dimensions that prioritized low-end torque over high RPM horsepower. The early 3406A used a mechanical fuel system with a mechanical governor, employing either pre-combustion or direct injection depending on the production year, all without electronic controls. The fuel system was simple enough that any competent diesel mechanic could rebuild it with basic tools, but robust enough to deliver precise fuel metering under the most demanding conditions. What set the 3406 apart was Caterpillar's obsession with rebuildability. The cylinder block was cast iron, thick enough to be bored out multiple times during overhauls. The crankshaft was forged steel, balanced to tolerances that ensured smooth operation, even after hundreds of thousands of miles. Even the connecting rods were designed with enough material that they could be reconditioned rather than replaced. The cylinder head design was equally robust. The valve train used mechanical lifters and push rods, components that could be adjusted with basic tools, and would run for hundreds of thousands of miles with minimal maintenance. The camshaft was gear-driven, eliminating potential timing issues and providing the precise valve timing that the engine needed for optimal performance. As deregulation hit in 1980, the 3406 became a popular choice for independent truckers who needed maximum reliability with minimum complexity. Early power ratings ranged from 250 to over 400 horsepower, with the B and C series commonly producing between 350 and 465 horsepower. But the real selling point wasn't peak power, it was the engine's ability to produce maximum torque at low RPM, exactly where heavy-haul truckers needed it. More importantly, buying a Cat meant joining a dealer network that understood trucking. Caterpillar dealers weren't just parts suppliers, they were partners who knew that a broken-down truck meant lost revenue, missed deliveries, and financial disaster for independent operators. The dealer network stretched from coast to coast with mechanics trained specifically on Cat engines. The engine's modular design meant that improvements could be incorporated without abandoning the fundamental architecture that made it reliable. This approach would prove crucial as the trucking industry evolved and demanded more power and better fuel economy. The 3406B, introduced in the mid-80s, represented the peak of mechanical diesel engineering. Caterpillar had refined every aspect of the original design while maintaining the fundamental simplicity that truckers trusted. Power ratings climbed to the mid-400s, but the real improvements were in the details that mattered to working drivers. The B-Series featured an improved turbocharger system that eliminated the mounting problems that had occasionally plagued early engines. The fuel injection system received upgrades with new nozzles that provided better fuel atomization and more complete combustion. The mechanical governor was improved to provide more precise speed control under varying load conditions. This was when the 3406 transcended mere machinery and became a cultural icon. The distinctive yellow paint became a badge of honor in truck stops across America. Drivers would gather around cat-powered rigs, sharing stories of mountain passes conquered and impossible deadlines met. To many cat drivers, there was an unspoken hierarchy in these conversations. Other engines had their supporters, but cat drivers occupied a special tier. The premium was real and substantial, but many truckers paid it willingly because they believed the cat would outlast and outwork the competition. This belief was supported by resale values that consistently favored cat-powered trucks. The mechanical simplicity meant that when problems did occur, they could usually be diagnosed and repaired by any competent diesel mechanic with basic tools. The 3406C, introduced in the late 80s, pushed the mechanical design even further. Common highway ratings for the 3406C ranged from 375 to 465 horsepower, with some versions tuned for higher output in specialized applications. The C-Series featured improved piston designs with better ring packages and enhanced skirt coatings that reduced friction and wear. The cooling system was refined with improved water pump designs. The fuel system received further improvements with new injection designs that provided more precise fuel metering and better response to throttle inputs. The air intake system was redesigned with improved filtration that extended service intervals and improved engine protection in dusty conditions. Another quiet advantage was oil analysis. Caterpillar's scheduled oil sampling program let owners trend wear metals, fuel dilution, and coolant intrusion. Instead of guessing, you could see bearings starting to go soft, or a liner seal weeping before it turned into a roadside failure. That moved decisions from panic to planning, and is a big reason many 3406 ran past 1 million miles between majors. Competition was fierce during this golden era. Cummins had the Big Cam and later the N14, engines that were gaining reputation for fuel economy and reliability. Detroit Diesel offered the Series 60 with its electronic controls, promising better performance and diagnostics. Both companies were gaining market share with aggressive pricing and promises of lower operating costs. But the 3406 held its ground through sheer reputation and proven performance. Fleet managers might choose other engines for spreadsheet reasons, but to many owner-operators the choice was simple. They believed Cat engines would last longer. This belief was supported by real-world experience with engines that many reported running past 1 million miles between major overhauls. Truckers routinely reported engines exceeding expectations for durability and reliability. The mechanical simplicity meant that diagnosis followed logical principles. If the engine wasn't getting fuel, air, or compression, the problem could be traced through mechanical systems that any experienced mechanic could understand. The dealer network mattered for uptime in ways that went beyond just parts availability. Cat dealers understood that truckers couldn't afford extended downtime, and they prioritized getting broken trucks back on the road. The beginning of the end came in 1993 with the introduction of the 3406E. The E stood for electronic, and it represented Caterpillar's attempt to modernize the 3406 for an era of increasing performance and tightening emissions. The 3406E was highly capable. Common on-highway horsepower ratings ranged from the low 400s up to 550 horsepower, featuring the electronic unit injection (EUI) fuel system for precise control, and built-in electronic diagnostics that greatly aided troubleshooting. In practice, the 3406E was where Caterpillar's legendary reliability began to unravel. The electronic fuel injection system replaced the mechanical simplicity that truckers trusted with computer-controlled complexity they didn't understand. The engine's performance was now managed by an electronic control module that monitored dozens of sensors and made thousands of calculations per second. When everything worked correctly, the 3406E was more powerful and more fuel efficient than its mechanical predecessors. The electronic controls could optimize performance for specific operating conditions, adjusting fuel delivery and timing for maximum efficiency or power as needed. The diagnostic capabilities could monitor engine health and alert drivers to potential problems before they became catastrophic failures. But when things went wrong, They went terribly wrong. The issue wasn't just emissions rules, it was repairability. With the 3406E and successors, failures changed from wrench-fixable issues to sensor, harness, and ECM problems that parked trucks and required shop computers. Downtime spiked, independents lost control of repairs, and confidence eroded, while rivals closed the gap on efficiency and support. Roadside fixes that had once involved fuel system adjustments, air system repairs, or mechanical governor tweaks became laptop diagnostics and code trees. Limp mode events from sensor faults meant toes instead of on-shoulder repairs, while harness chafe and connector issues replaced the wrenchable failures that mechanics had handled for decades. The diagnostic systems that were supposed to make troubleshooting easier often made problems worse, with error codes pointing to expensive components that weren't actually faulty. To many CAT drivers, this felt like a betrayal of everything the 3406 had represented. The company that had built its reputation on mechanical simplicity and bulletproof reliability was now selling engines that required computer technicians instead of diesel mechanics. The relationship between driver and engine had fundamentally changed. Instead of understanding how their engine worked, drivers now had to trust electronic systems they couldn't comprehend or repair. Caterpillar's Assert technology introduced advanced emissions controls with multiple injection events and exhaust gas recirculation, increasing maintenance complexity and leading to some emissions-related reliability challenges. Truckers who had sworn by CAT engines for decades began defecting to Cummins and Detroit Diesel. The ISX and Series 60 engines weren't perfect, but they had been designed from the ground up as electronic engines. Their manufacturers had learned to make reliable electronic controls because they had no choice. They didn't have a mechanical heritage to fall back on. By the time Caterpillar exited on-highway in 2010, many owner-operators felt the relationship had been abandoned. The announcement stunned the industry that had grown up with CAT power. Truckers who had planned to buy CAT-powered trucks for the rest of their careers suddenly found themselves shopping for engines from companies they had spent decades dismissing as inferior. While truckers felt abandoned, Caterpillar's reputation in other industries remained unshaken. The same engineering philosophy that had made the 3406 legendary in trucking found new purpose in applications where mechanical simplicity was still valued over electronic sophistication. The 3406 were still widely used in marine applications, including commercial fishing vessels, tugboats, offshore supply boats, and was specified by some sport fish builders such as Hatteras and Viking. The engine's ability to produce strong low-end torque made it ideal for marine propulsion, where constant speed operation was more important than the variable loads of highway trucking. Commercial fishing boats operating in harsh conditions relied on 3406 engines to power through heavy seas and maintain position in challenging weather. Marine ratings are about duty cycle, not peak numbers. Propeller load rises roughly with the cube of RPM, so engines live or die on steady torque at sensible speeds. The 3406 family's torque curve and heavy rotating assembly suited continuous and heavy intermittent ratings, with heat exchangers and aftercooling handling constant load. That combination, plus parts availability in major ports and support from sport fish builders, explains why so many 3406s found long second lives at sea. The mechanical fuel injection that had become a liability in highway applications was an asset in marine use where salt air and moisture could wreak havoc on electronic systems. A fishing boat operating hundreds of miles from shore couldn't afford to depend on computer diagnostics. They needed engines that could be repaired with basic tools by crew members with mechanical knowledge. The 3406's low-end torque characteristics were particularly valued in tugboat operations. The ability to produce strong pulling power was exactly what was needed for ship assist and barge towing operations. The engine's reputation for reliability was crucial in applications where failure could result in maritime accidents or environmental disasters. Construction and mining operations embraced 3406 power for similar reasons. The constant dust, extreme temperatures, and heavy loads of these applications were exactly what the 3406 had been designed to handle. In quarries and mines, where equipment might operate in conditions that would destroy lesser engines, the 3406's robust construction and simple maintenance requirements made it a preferred choice. The aftermarket support that had made the 3406 legendary in trucking continued to serve these industrial applications. Caterpillar's dealer network remained strong in construction and mining markets with parts availability and technical support. The company's commitment to supporting older engines meant that 3406s could be kept running for decades. In these applications, the electronic controls that had proven problematic in highway use actually provided benefits. The precise fuel metering of the electronic injection system improved fuel economy in constant load applications, while the diagnostic capabilities helped maintenance crews schedule repairs during planned downtime rather than waiting for catastrophic failures. In stationary power generation, the 3406 found new purpose as the heart of emergency generators and standby power systems. Hospitals, data centers, and other critical facilities relied on 3406 powered generators to provide backup power when the electrical grid failed. The engine's ability to start quickly and run at full load indefinitely made it ideal for these applications, where reliability was literally a matter of life and death. The marine market proved particularly loyal to the 3406 platform. Yacht builders continued to specify 3406 engines for large motor yachts, where the combination of power, reliability, and global service support outweighed any concerns about fuel economy. Commercial operators valued the engine's ability to run for thousands of hours per year while maintaining its reputation for durability.